So in this video we will be talking about the slider crank, all its inversions. Okay. So you can see here the links are attached like this. There are total of 4 links. One is the yellow, which is sliding inside the green slider. Then we have the pink one. Okay. You can see the slider, it is like this. The pink one, which is the coupler, and the red one, which acts like a what? Crank. So let us see how the motion occurs when the yellow part is fixed. The yellow link here is fixed, and we'll be rotating the red part, which is called as the crank. So this is how the motion occurs. Fine. So the red link will rotate complete 360 degrees, and hence it is called as a crank. And that crank is connected to the slider by way of a coupler, which here you can see it pink in color. Okay. So this is called slider crank. So this is the first inversion of slider crank, wherein the yellow part is fixed. Now let us see the different inversions of the same mechanism. The first that we come across is what? Whitworth. So this is the Whitworth. Okay. So here the red link that we can see here, the link which was crank in the previous case, that is fixed here. So next we will just rotate the pink mechanism and see how the rotation occurs. Okay. Getting it? So this is how Whitworth mechanism will function. Actually this mechanism that you can see here, it's not complete Whitworth. There are some parts which are absent. The yellow link that you can see here, it is extended on the back side. The yellow link is actually extended on the back side. Fine. And that extension of the yellow link is connected to a ram. Is connected to a ram. Fine. And when the pink link rotates, it will rotate with constant velocity. It will rotate with constant velocity. Fine. So at this position the ram is in one extreme, and when it comes this side it is in the other extreme. Fine. So the angle rotated by pink link from this point, the angle rotated by the pink link from this point over here to the extreme on the other side, to the extreme on this side, it is more. Okay? So it is moving all this point. Okay, this much angle it has to rotate. Correct? Whereas the angle that it is rotating for the bottom part is much less. Okay? For the bottom part, the angle rotated is much less. Fine. So the angle which is rotating for bottom part is much less. The angle which is rotating for the top part is much more. That's what results in the quick return motion. Okay? So this is used in the slotting machine. You can see the machine when you go to the lab. Next is the oscillating cylinder mechanism. Let's again see how it functions. So I'll place it like this. Okay. So the pink link that you see here, that link is fixed, and the red link becomes the crank. Okay? And the motion occurs like this. The motion occurs like this. Can you see it?
Yes, sir.
Fine. So this is the this is the oscillating cylinder mechanism. Okay? So the green part here that you can see here, that is actually constructed in the form of a cylinder, and that cylinder will be oscillating. That cylinder will be oscillating to and fro. Fine. So I'll share you the other video from Ujjwal Rane, who has created a similar mechanism. It's a micro station, and he has shown clearly how the cylinder is placed. So my aim here was to show you the same mechanism by fixing different linkages, how it functions. Then there is a small variation of this mechanism, right? There is a slight variation of this mechanism, which is called as slotted lever mechanism. The one you can see at the side on the board. Okay? So at the side I've drawn small. So this is a variation of the oscillating cylinder mechanism. Okay? So now again the pink link here is fixed, At the red link, we are rotating it. Getting it? So when I am rotating, you can observe that it is returning very fast. Right to left, it's going very fast. Left to right, it's coming very slowly. Okay? So this is also a quick return mechanism, and you can find the quick return ratio as I have explained on the board. Clear? So this is a small variation of the third inversion itself. It's a small variation of the oscillating cylinder. Even though it looks very, very similar to Whitworth, it's actually a variation of oscillating cylinder mechanism. Then coming to the hand pump. Fine. So the hand pump is like this. Okay. So once again, I have not shown the extension as I have shown on the board. So you just have to imagine that there is an extension on one side, and as I am rotating here, I will just rotate here for complete 360 degrees. Okay. So can we call this red link as crank? No, we cannot call it. We cannot call it as crank even if it rotates 360 degrees unless its center is fixed. The center of this link, you can observe here, is it fixed?
Yes sir, it is not fixed.
Not fixed. It's moving. Okay? So hence this red link we cannot call as a crank in this case. Okay? So one side of this red link is extended, and that is used as a handle for hand pump. It's used as a handle for hand pump. Clear? Okay? So this is another variation of the same, of the quick return mechanism. Not hand pump. So what is this? Slotted lever. This is slotted lever, which is a variation of oscillating cylinder. Oscillating cylinder. So here I have shown the slotted lever. You can see there is a slot in the lever. The green part is the slot.
That is
slotted lever. Okay. So it can become a slotted cylinder if this part is fixed here at the center. Okay. So that same cylinder is actually converted into a slotted lever. Okay. So that's why I am telling it. It is the variation of the oscillating cylinder and not of the Whitworth. Fine. And not of the Whitworth. So this is clear?